Conclude this chapter 10. This is section 10.3, and we're going to be looking at the cross product between two vectors in space, and then a use for the cross product. Here's what we've got. A vector in space that is orthogonal. Remember orthogonal, what that means is it means perpendicular to two given vectors is called their cross product. We have a formula that we're going to use to find the cross product, and then I will also show you an alternative method in case you're not too keen on trying to memorize a big formula. Here it is. If u is a vector, so here we got a vector in linear combination form, and here is another vector v, linear combination form. The cross product of u and v is this vector. So this is the symbol for cross product right here, u x v. You take u2, multiply by v3, subtract u3, multiply by v2. So you can see here in this first component, you are basically taking out the i's, or the u1 and v1, and you're doing cross product with the other two. And then what we've got is minus u1 v3 minus u3 v1. And again, so here you're in the second component, you're taking out the j's like this. And you're doing their products and then subtracting j. And then on the last section, u1 v2 minus u2 v1 times k. See, you're taking out the third component and you're doing u1 times v2 minus v2 u2 times v1. Anyway, so you do all the cross products here of those, the pieces that are left. I have another way to show you that might be helpful besides this formula, but do take some time to write that down. Here's a possible method to use. All right, so what I usually do is I create a matrix, and this matrix will be like this row right here is a matrix with one of the vectors, so the three components of a vector, and this is the other three components, second vector. Okay. Now the cross product will equal, if you ignore this first row for a second, then this right here is the determinant of what's left. Okay, so you do u2, u3, v2, v3, so you're going to do the determinant of that. Okay. Then you come back, and the second component, the j component, you ignore the j's, you take those out, and you create a matrix that's 2 by 2, and it's the ones that are left over, u1, u3, v1, v3, and then you find its determinant. So it would be the determinant answer times I, the determinant answer times j, and it's minus in between, and then plus, it'll be the determinant of the last one times k. And here's how we get the last one. You can ignore the k's. So you kind of ignore these. And you make a matrix u1, u2, v1, v2, and you do the determinant. Okay, so that's the method that I use. Let's go ahead and take a look at an example here. So we've got I, j, k, my first vector, -2, 3, -3, and then my second vector, 1, -2, and 1. So like this is my matrix. And the cross product then. Cross product of u times v. So I'm going to ignore my first column, and my matrix here would be, or my determinant would be using 3, -3, -2, and 1. minus, now you ignore the middle column, -2, 3, 1, -2, and plus, and these all have, I, and then j, and then k with it. And then the third column you ignore, so it's -2, 3, 1, and -2. So let's go ahead and do the determinant of each of these. We've got 3 minus 6, so it's -3i. 4 minus 3 is 1, so minus 1j. 4 minus 3 is 1, so plus k. So this is your cross product between u and v. All right, so I think that this method here is the method you might want to choose instead of trying to remember the formula and which parts to multiply, because this kind of lines it all up for you. We do have some properties. The first property that we're going to look at is whether or not you have the commutative property, and we don't. The cross product of u times v is actually equal to the opposite of v cross u. We have a property that allows us to use like the distributive property, so it's u cross product v plus u cross product w, so that's true. We also can multiply by a scalar. When you multiply by a scalar, you can't multiply by both, but just one of them. So it's either cu cross product v or it's u cross product cv, one or the other, but you do not distribute both. When you cross product with a 0 vector, you get 0. And when you cross product a vector by itself, you also get 0. And finally here, if you are multiplying or doing a dot product with a cross product, the dot product with a cross product, what we can do is you can switch the order. So we could actually make this as u cross product v dot product w. So that's somewhat like the associative property, being able to change the parts. We also have some geometric properties that we'll look at. We've got u cross product v is orthogonal. And remember what orthogonal means. It means that it's perpendicular to both of the vectors, the original vectors, so both u and v. So when we find the cross product, that result is a vector, and that vector is perpendicular to both of those vectors. All right, here we've got the magnitude of the cross product, and the magnitude is equal to, so we just have another formula here. It's the magnitude of u multiplied by the magnitude of v, and then multiplied by the sine of theta. So that's what that looks like. U cross product v equals 0 if and only if u and v are scalar multiples of each other. Which means that if they're parallel to each other. And finally, the cross product, or the magnitude here of the cross product also equals the area of a parallelogram. Area of a parallelogram, I'll just do the symbol here, having u and v as adjacent sides. And adjacent sides means that they share a vertex. And so here's where we're going to, use our application problem. We are going to be using the cross product and the magnitude of it to find the area of the parallelogram. All right, so example 2 here says find a unit vector that is orthogonal to u and v. Well, a unit vector orthogonal to u and v would be this. Let's find its cross product. And if we find the cross product, if we find the cross product here, what we can do, let's go ahead and set up the matrix. So we've got I, J, K, 1, negative 2, negative 3, and so that's I, J, and K. I don't have an I here, so that's 0, 4, and negative 5. So we've got the cross product. Let's go ahead and do our determinant. So the determinant would be negative 2, negative 3, 4, negative 5, minus the second determinant would be 1, negative 3, 0, negative 5, and the third determinant would be 1, negative 2, 0, and 4. So what we've got is, this is 10 minus negative 12, that's 22i. That's negative 5 minus 0, so minus a negative 5 is plus 5j. And here we've got 4 minus 0, so plus 4k. All right, well, this is a vector, but it's not the unit vector. So if we're finding a unit vector, I need to take this vector of 22, 5, and 4, and I need to divide it by its magnitude, the square root of squared would be 484 plus 25 plus 16. That's 525. Just doing the magnitude here. The 525 also can be written as, if we divide by 25, it would be 5 square roots of 21. So let's go ahead and continue to write this and rationalize at the same time. So here's my unit vector. It's 22 square root of 21 over 5. The second one, the 5's would actually cancel, so it's just the root of 21 over 21. This is going to be 21 times 5 here. Hold on a second. So 105. And the 5 and the 105 can be divided. And that's 21. And here we would have 4 square root of 21 over 105. All right, so there's your unit vector. All right, so the last thing that we're going to do is a problem with the parallelogram, and we need to, I'm going to show you some things here with trying to plot these points, because when we go with these points on this parallelogram, this is going to be my x-axis coming through here. It's difficult to do this three-dimensional thing on a surface that's 2 dimensions, but this is my x, this is my y, and this is my z. Find the area of a parallelogram with these vertices. So let's go ahead and plot 1, 1, 1. All right, that's let's go ahead and do a few marks here. We can just do up to 3 or so. All right, 1, 1, 1 would be, here's 1, and then to the right 1, and up 1. So we're about right here. The point that I'm going to plot here is 2, 3, negative 1. So 2 over 3 and then negative 1, so it'd be about right in here. And that is Q. And R is negative 1, negative 2, and positive 2. So it's about in here. And then finally S is the origin. So when we go to represent this parallelogram, it's important to know that we're not crossing over. So my parallelogram is going to be this. R to S, S to Q, and then from Q to P. Okay, so you'd have to visualize this parallelogram if you'd have to tilt the axis to the side. But the main thing is that my parallelogram, the order of the points would have to be, I'm going to start with P. So P, Q, S, R, not RS, not in the order here that they're listed. So P, Q, S, R is my parallelogram. With that being said, if we're wanting to find the area of the parallelogram, what we need to do is we need to figure out at least 2 vectors. And then the 2 vectors that we want to use are the ones that are adjacent to each other. And since I've got a vector here at the origin, I'm going to use the origin as the initial point for both vectors. So we're going to find vector SP. Okay, so vector SP would be the vector 1, 1, 1. And then I'm going to find the vector from S to Q. And that vector is 2, 3, negative 1. All right, so we're ready to do the cross product. So we have to do the magnitude of the cross product. This is how we find our area. So these are my vectors, and if I set up my matrix, it'd be I, J, K, 1, 1, 1, 2, 3, negative 1. And so my first determinant would be 1, 1, 3, negative 1. That's eliminating the first column. My second matrix is 1, 1, 2, negative 1. And my third matrix, or determinant, is 1, 1, 2, 3. So the determinant here is negative 1 minus 3, that's negative 4, I, minus negative 1 minus 2 is negative 3, so minus negative 3 is plus 3J, and 3 minus 2 is plus K. All right, that's the cross product. Now magnitude of it. Okay, the magnitude of that would be the square root of 16 plus 9 plus 1. So this is the square root of 26. Your area is the square root of 26 units squared. Square units. All right, so there you have it. So I basically plotted my points. I found this is 2 consecutive vectors. And then you find the cross product of the 2 vectors right there, and then the magnitude of it, and that gives you your area. Here is your assignment.